Okay, so let me do problem number 1. Find the value of theta in degrees, round to the nearest tenth of a degree. Okay, so we have the following. Okay. Okay, so I have here, I want to figure out theta. Okay, and these are right angles, and this is a 3. That's a 12. Okay. And so then this is, I guess, let's call it theta over 2. This angle. Okay, so we have, actually, well, yeah, eventually I'll probably need that. And let's call this, oh, something. So this is 3, I know that. And this has got to be 12 also. Okay, and so let's call this, find the value of theta. I can do it in either way. I can call this either x or x minus 15. I guess I'll call it x. Okay, so I have that 3 over x is the same as 12 by similarity of triangles over x plus 15. Okay, so let's try to figure out what x is. So I have that 3x plus 45 equals 12x. And so 45 equals 9x, so x is equal to 5. Okay. Oh, this is I thought it was a 3, 4, 5 triangle. It's not. It's a 5 there. Okay. So I have that. Oh, I can do tangents. I have that tangent of theta over 2 is equal to 3 over 5. So that says that theta is equal to 2 arctan of 3/5. Which is approximately there it is. 2. Oh, and let's see, wait, let's do this in degrees. Oops, degrees. So 2 arctan of 3/5. 61 .9275 .75 9275 1306 degrees. And round to the nearest tenth of a degree. 61.9 degrees. 2. An aircraft there is at Z, so at some point Z, is spotted by observers at X and Y who are 1,500 feet apart. As the plane passes over the line joining them, each observer takes a sighting of the angle of elevation to the plane. If A is 25 degrees and B is 30 degrees. How high is the plane? So I want to figure out H. Okay, so let's figure out that. So let's call this X, and let's call this 1,500 minus X. So this is feet, and these are feet. Okay. So I have that. Oh, and I have an H in common. Okay, so I have that the tangent X tangent of 30 degrees is the same as, so that's H, which is tangent of, so the tangent is the opposite over the adjacent. And so the adjacent times the tangent of 30 degrees is the opposite. And so this has got to be the same situation. Oh, sure. And so I have that the opposite over the adjacent is the tangent. And so the opposite H is 1,500 minus X times tangent of 25 degrees. Okay, so I have that X tangent 30 degrees is equal to 1,500 tangent 25 degrees minus X tangent 25 degrees. Okay, so I have that X tangent of 30 degrees plus x tangent 25 degrees is equal to 1500 tangent 25 degrees. So that says that x is equal to 1500 tangent 25 degrees over tangent 30 degrees plus tangent 25 degrees. Okay, so I have that h, which is, let's do it as a tangent again. H is equal to x times tangent of 30 degrees. And so it's just 1500 tangent of 25 degrees times tangent of 30 degrees over tangent 30 degrees plus tangent 25 degrees. And that's the height. And so let me give an approximation to that. 1500 tangent 25 degrees tangent 30 degrees over tangent 30 degrees tangent 25 degrees. It is 386.941226 feet. So that's the approximate amount. Yes. Question on number 1. Oh, there it is. Question on 1. Why did I decide to go tangent? I could have done any of them, but I'm looking at this upside down. You stupid. I did it wrong. It's not tangent. It's sine. I'm sorry. Uh-oh. I'm looking at this upside down. And so I have that this is, oh, it's a 3, 4, 5 triangle. So this is the, because I wrote it upside down. So this is my angle, theta over 2. That's a right angle. That was a 3. But the x is opposite the right angle. And that was a 5. Uh-oh. It is sine. Okay, so I'm wrong. That's a sine. I wrote the wrong. The answer is actually, I wrote it wrong. Because this is a, if it was a tangent, it should have been 3 over 4. So I wrote it wrong. Okay. So that's the answer why. It's because I wrote it incorrectly. There's a typo there. Well, it's because actually it was a visualization problem of mine because I wrote it upside down. This is the hypotenuse here. So this guy here, these are hypotenuse. So it's the opposite over the hypotenuse, which I should have known because that's a right angle. Therefore, it's opposite the right angle, which is the hypotenuse. So that's why it's a sine. Yeah, well, no, the other one would have worked. You see, you would have had to have written it, since this was a 5 and this was a 3, and this is your unknown angle. You would just have to figure it out. This other guy, say the 4, then you could have gone tangent as 3 over 4, or cosine as 4 over 5, or sine as 3 over 5. So you could have used any of them, but since I only had the 3 over 5, the easiest would have been to have used the sine. And so let's do this. So it's the sine 2, so it's completely wrong, 2 arcsine of 3/5. Okay, 73.739. Yeah, so that's 0.739, 79529, 75929 degrees. 75. Okay, 73, 73, 97, 97, 97, 95, 29. 95, 29 degrees. Okay, so sorry about that. That was a typo. Well, actually, worse than typo. This is a real error on my part. Okay, problem number 3. Given a triangle whose sides are, I don't know, 13, 19, 20, and I don't know, let's call this A, B, C. So I can use the law of cosines. Then this will have just one answer. And so B squared. So, oh, maybe I should write it. But this is a C. And that's a B. So A squared plus B squared equals C squared. Okay, so I have 20 squared equals 13 squared plus 19 squared minus 2 times 13 times 19 cosine of C. Okay, so 20 squared if you're going to be an engineer, yes. So the answer is yes. If you're going to, for engineering, the answer would be certainly yes. So 400 equals 169. I don't know what that is. 180. Let's do 20 squared. 400. Good. What was the other one? 19 squared. 361. 13 squared. 169. 2 times 13 times 19. 494. Sine C. And so 400 equals 169 plus 161. 530. Okay, good. And so you get that 494 cosine is equal to 130. And so C, 130 divided by 194, you can divide it at least by 2. 65 over, well, let's do that. 130 over 494. Oh, 5 over 19. Okay. So C equals our cosine 5 over 19. Hmm. Oh, I subtracted 400 from both sides. I just brought the 494 cosine. So I subtracted 530 from both sides and then changed the sign. So 400 minus the 530 gave you the 130. Okay. So now I can do law of sines. So let's say sine of A, no, sine of C, which is that stuff, over C20 equals, oh, I don't know, let's say, let's do B. Sine of B over 13. Okay, let's see if I have some angle C. And the cosine is 5 over 19. 25 minus 361. 336. Wait, let's just check. Can I actually do that? 19 squared minus 5 squared. 336. No, it's not. It's close. Okay, 336. 84. 21. So that's 4 rad 21. Yes. Okay. And so I have that sine is 4 rad 21 over 19 equals 20 over 13 sine b, just multiplying both sides by 20. So now I get sine of b is equal to 4 times 13, 52, rad 21 over, oh, I should just reduce it at the end then. This is equal to, cross multiplying, so it's 4 times 13 rad 21 over 19 times 20. So you can cancel those. Okay, so it becomes 13 rad 21 over 95. And so B is inverse sine of 13 rad 21 over 95. Okay, and then lastly, I have the sine of C over 20 is equal to sine A over 19. So that says that the sine of C is equal to 20 over 19 times the sine of A, which says that, that becomes nicer. The 19s cancel. So it says the sine of A is equal to radical 21 over 5, since the 20 divided by 4 is 5. And so that says that A is equal to inverse sine of rad 21 over 5. Okay, so finally we get A is 19, B is 13, C is 20, A, arcsine of radical 21 over 5. Oh, this is going to be in degrees. Doesn't matter. In degrees. Okay. Arcsine (21 divided by 5). Arcsine 21 divided by 5. Okay. 66. 421. 421. 821. I think 52. Yes. Okay. B is arcsine 13 rad 21 over 95, which is 13, 21, 95. 13, 21, 95. Okay. 38, 83, 38, 83, 83, 5, 70177, 70177. Okay. Good. And lastly, C is cosine inverse 5 over 19. Seventy-four, 24, 76, 71. And that is your triangle. Okay. 4. Maybe I'll just do the part of it. Okay. So 75 degrees. This is 4 feet. And I want to figure out this area. Okay. So the area of a sector is 1/2 r theta square, r squared theta. Actually, maybe I write them here. So this is so, and this is r. And then the area of a triangle is 1/2 AB sine theta. Okay. So the area that we want is the area of the sector and in this case, for this formula to work, the area of a sector, this has got to be written in radians minus 1/2 AB sine a theta. It really doesn't matter if I write this in degrees or in radians. Okay, so this is equal to 16, so that's 8 times 75 pi over 180. You can divide that by 4. Get a 2 there, and you get a 45. divided by 5. Get a 9 here. And actually divide by 5. So you get a 3. Divide by 15. You get a 3 and you get a 5. Okay. Minus. These cancel. So you get 8 sine 75 degrees. So this is going to equal 10 pi over 3. Let me just check. 8 times 75. Ten over 3. Yep. Minus 8 sine 75 degrees. And that is the area in, I think, yeah, these are feet, square feet. And so it is approximately 10 pi over 3. 10 minus 8 sine 75. 2.74. 568. 902 square feet. So that's the approximate area of that little piece there. Okay, 5. Find the equation of a parabola whose vertex is at -2, -4, and whose focus is at 0, -4. Okay, so first off, if you notice, well, let's have to draw a grade. So this is x, y. So the focus is at -2, -4. So we're down here. And the focus is at 0, -4. And so your parabola looks something like this. So the equation of it is going to be x squared. Why did I write x squared? Don't know. Y minus k squared equals 4. For px. Okay. And so I have that y minus a -4 squared is equal to 4 times p. P is the distance from, from your vertex to the focus, in which case this is a 2 times 4 is 8, x minus a -2. And that is the equation of your parabola. Any questions about that? Okay. Oh, that was A. B. Find the vertex, etc. X minus 1 squared equals 8. X minus 2. Okay, so find the vertex. Well, the vertex is at 2, 1, because, well, that's what these are. So that's your vertex. The focus. Okay, so this is a y squared, so again, it's going this way. And I have that 8 is for p, so p is 2. So that means you're going 2 in the x direction from the vertex. So that's going to be at 4, 1, just like what you did up here. And the directrix. Oh, the directrix is, again, it's going to be an x equal. And instead of going 2 in this direction, you're going to go 2 in the opposite direction from your vertex. So subtract 2. So it's x equals 0. And that is the vertex, focus, and directrix for that particular parabola. Okay. Problem number 6. So we happen to have a suspension bridge, and so you have a parabola. It looks like this. And this is 500 long. So this is at 250, negative 250. And the height here is 100 feet. And you want to figure out the value of this at 125 feet. Okay, so I know that y equals ax squared is the equation, because it says here, the cables of suspension bridge are in the shape of a parabola, as shown in the figure. The cables supported, the towers supporting the cable are 500 feet apart, so that's why they're at 250 and 250. And if 100 feet high, so this is why this is at 100. If the cables touch the road surface midway between the towers, so that's why it's going here. What is the height of the cable at a point 125 feet from the center of the bridge? So that's what you want to figure out. And so this vertex here is at the origin, and this parabola goes up, so it looks like this. When x is 250, y is 100. So I have that 250 squared uh, 60 to 500. Divide by that, so A is equal to 1 over 625. So it says that y is equal to x squared over 625. So now it says, what is the height when x is 125? The answer is 25. Okay. Any questions about that? Okay. 7. Ah, yes. Question. How does 125 play the role? Because that's where we're plugging in. So it just asks how high is the cable above the ground 125 feet from it. So at the very end, we just want to plug in 125 into this equation. So it's just that so it doesn't, it's, once you figure it out what the equation is, you just at the end want to figure out, well, if you plug in 125 into your equation, what is the height? What's y? Okay. Okay. Problem number 7. Uh, x. So you have a ellipse. X plus 2 squared 4y minus 2 squared equals 100. So I have x plus 2 squared over 100. Y minus 2 squared over 25 equals 1. Find the center, foci, and vertices. Okay, well, A in this case is 10. Square root of 100 is 10. B in this case is 5. Square root of 25 is 5. C in this case is 100 minus 25 is 75. So it's the square root of 75. 5 rad 3. And so now it says to give me the center. The center is at negative 2, 2. Just looking here at the equation of your ellipse. The foci are at 100 is bigger than 25. So I'm going to be adding, subtracting the 5 rad 3 to the x. And the vertices, you're going to add and subtract 10 from the x. You're going to add and subtract 5 from the y. And that gives you the centers, the vertices, and the focus. Any questions about that? Okay. For the vertex, probably. It's just 2 or 21. It is, so here the vertex is at negative 2, positive 2, because you're subtracting a negative 2 here, and you're subtracting 2. So the center of your ellipse is negative 2, 2. Then, to figure out the vertices of your ellipse, you'll be adding to the x coordinate 10 and subtracting 10. So that's why you get a negative 12 here. And then negative 2 plus 10 is 8. For the y, you'll be adding 5 and subtracting 5. And so you subtract 5 here, so that's why you get a negative 3. You add 5 here, that's why you get a 7. Did that answer your question? Okay, it did. Okay. Ooh, now I understand what it was. You thought that was 21. Aha, okay. Those are parentheses. Yeah, those are bad parentheses. Yes. Okay. Yeah, that was okay. Problem number 8. Problem number 8. Find the center. Foci vertices. So same question. 9x squared, 36y squared, 36, 216, 36. So this is 9x squared minus 36x, 36y squared, 216y equals negative 36. Okay, so now 9. So first I group all the x's and y's together. Now let's factor out a 9. So it's x squared minus 4x. Factor out a 36. It's y squared plus 6y equals negative 36. And so now let's complete the square. So we have a 9x plus 36y equals whatever. Okay, so since there's a 1 in front of the x squared, I take negative 4 divided by 2 is a negative 2. Negative 2 squared is 4. 4 times 9 is 36. 6 divided by 2 is 3. 3 squared is 9. 9 times 36 is 54 and 27, 324. Okay, so this is 324. And so I have dividing both sides of my equation by 324. Actually, it doesn't matter. It's just 9 times 36. Okay, so I get x minus 2. Oops. Squared over 36. Y plus 3 squared over 9 equals 1. Okay, so A in this case is 6. Square root of 36 is 6. B in this case is 3. Square root of 9 is 3. 36 minus 9 is 27. So C is the square root of 27. 3 rad 3. And so this, I want to find the center. The center of my ellipse is 2, negative 3. The focus, 36 is bigger than 9, so I'll add to the x. And so the focus is at 2 plus or minus 3 rad 3, negative 3. And the vertices are, and maybe I'll just write it in the plus or minus form, is 2 plus or minus 6, negative 3, and 2, negative 3 plus or minus 3. So those are your center, focus, and vertices. Okay, 9. Solve this system of equations. Okay, so let me do that. Oops. X minus 2y plus 3z equals 11. 2x plus y plus z equals 2. Negative 3x plus 2y minus 2z equals negative 14. Yes. Yeah. Oh! Problem number 9. I skipped the problem. Okay. Let me do problem number 9. They all sort of look the same after a while. X minus 6 squared over 36, y plus 4 squared over 25 equals 1. Okay, so A in this case is 6, square root of 36 is 6. B in this case is 5, square root of 25 is 5. 36 plus 25 is 50, 61. And so C is the square root of 61. I want to find the center. So the center of my hyperbola is the point 6, negative 4. I want to find the transverse axes. Well, since the x is positive, then the transverse axes will be where the two foci are, which in this case is going to be along the x. Oh, notice the center is at 6, negative 4. And so this is just going to be y equaling negative 4. That will be your transverse axis. The foci, well, again, this is going to be along the x-axis. So you're going to be adding and subtracting to the x. So it's going to be 6 plus or minus rad 61, negative 4. The two vertices, again, you're going to be adding to the x here to get my two vertices. And so you'll be adding, subtracting 6. Maybe I'll actually write them down. So if you subtract 6, you get 0. Subtracting 6 from the x-coordinate of the center and adding 6 to the x-coordinate of the center. And then lastly, you want to figure out your asymptote. And so the asymptote is going to be y plus 4 is equal to plus or minus b over a, 5 over 6, x minus 6. And those are your answers. I can get rid of that horrible sketch to help you. Any questions about that? Okay, let me do problem number 10 now. 10. Maybe I'll just I'll write this as a matrix. And so 1, 2, -3, -2, 1, 2, 3, 1, -2, 11, 2, -14. Okay, so let me pivot. One, -2, 3, 11. Okay, so let's take row 2, subtract from it 2 row 1 to give me a new row 2. 2 minus 2 is 0. 1 plus 4 is 5. 1 minus 6 is a -5. 2 minus 22 minus 20. Now let's take row 3, add to it 3 times row 1 to give me a new row 3. 3 plus 3 is 0. 2 minus 6. 9 minus 4. 22. 33. Sorry. 3 times 11 is 33 minus 14 is 19. Okay. So this is equal to 1, -2, 3, 11. Let's divide by 5. 0, 1, -1, -4. And then let's multiply by 4. So multiply row 2 by 4 and add it to row 3 to give you a new row 3. So you get a 0. 4 minus 4 is 0. 5 minus 4 is 1. 19 minus 16 is 3. Okay, so now let's back substitute. So I have that z is equal to 3. I have that y minus z is -4. So y equals -1. And lastly, I have that x minus 2y plus 3 is z is 11. So x plus 11 is 11. So x equals 0. So my solution is 0, -1, 3. B. X minus y minus z, 4. x minus y minus z is 4. 4x plus 3y plus z equals 5. 15x plus 6y is equal to 0. Okay, let's pivot. Oh, and I forgot I was pivoting there. So let's pivot. One minus 1, 4. So I'll take row 2, subtract 4 times row 1, give me a new row 2. Okay, so 4 minus 4 is 0. 4 plus 3 is 7. 4 plus 1 is 5. 5 minus 16 is 11. Let's take a row 3, subtract 15 times row 1, give me a new row 3. 15 minus 15 is 0. 15 plus 6 is 21. 15 plus 0 is 15. 15. Oh, that's no solution. 15 times 4 is 60. So I have a negative 60. Okay. So, I have here 1, negative 1, negative 1, 4, 0, 7, 5, negative 11. And last, let's do row 3 minus 3, row 2 to give me a new row 3. 0 minus 0, 0. 21 minus 21, 0. 15 minus 15, 0. 33 minus 60 is, I don't know, 27. Plus 33, 50. Yep, but doesn't matter. Here it says 0 is equal to negative 27. So that's a contradiction. So this is an inconsistent system. This equation has no solution. This system of equations has no solution. Okay. C. X minus y minus z equals 2 minus x plus 2y minus 2z equals negative 7. 5x minus 3y minus 11 equals 0. Okay, so let me pivot. 1, negative 1, negative 1, 2. Okay, so let's do row 2 plus row 1 to give me a new row 2. 1 minus 1 is 0. 2 minus 1 is 1. Minus 1 minus 2 is minus 3. 2 minus 7, negative 5. Let's do row 3 minus 5, row 1 to give me a new row 3. Okay. 5 minus 5 is 0. 5 minus 3, 2. 5 minus 11. And then 5 times negative 5 times 2 is negative 10. Okay, so let's pivot. So 1, negative 1, negative 1, 2, 0, 1, negative 3, negative 5, row 3, minus 2, row 2, gives me a new row 3. Zero minus 0, 0. 2 minus 2, 0. 6 minus 6, 0. 10 minus 10, 0. Okay, so there's one row of all zeros, so I know that this will have a one parameter family of solutions. There'll be an infinite number of solutions. I'll say that first. Okay, and this will be a one parameter family of solutions. Okay, so that was a lot, yeah. And that's because there's a whole, notice you have 0x plus 0y plus 0z equals 0. And so basically, this is now overdetermined because you really only have two equations and three unknowns. And so undetermined. So that means that because of that, you're going to have a lot of solutions, an infinite number of solutions. And because there's just this one row of all zeros, that's why it's a one parameter family of solutions. So now let's figure out what it is. I don't know. Let's call it the parameter, or say alpha or something. So let z equal alpha. Then from the second equation, I get y minus 3z equals negative 5. So that says that y equals 3 alpha minus 5. From the first equation, I get x minus y minus z is equal to 2. So you get x minus 3 alpha plus 5 minus alpha equals 2. So x minus 4 alpha plus 5 is 2. Add 4 alpha. Subtract 5 from both sides of your equation. And so my one parameter family of solution, therefore, is 4 alpha minus 3. Y is 3 alpha minus 5. And z is alpha. And this is for all real numbers, alpha. And that is your one parameter family of solutions. Did he have you write it in this fashion, or did he have you write it as a line? Or do you remember? Uh, there's more than one way to write these. For this, you can't use a calculator. Yeah. For these, because it's an infinite number of solutions. So it's probably something like this is what he wrote the answer as. Okay, that was C. Let me do problem number 11. And so A. B. C. So A. 2A plus 3B. So 2A, 0, 2, minus 12, 2, 10, 2. 3B, 9, 3, 0, negative 15, 9, negative 12. Add 9, 5, negative 12, negative 13, 19, negative 10. Just adding up components. Okay, any questions about that? B. Oops. Okay. Find B times C. So B, 3, 1, 0, negative 5, 3, negative 4, 4, 3, negative 4, 1, 5, 6. This is not going to be hard, but it's going to involve a lot of calculations. 3 times 4, 12. 1 times 3, 3. 12 plus 3 is 15. 0 times negative 4 is 0. So 12 plus 3 plus 0 is 15. Do the next. 3 times 1, 3. 1 times 5, 5. 0 times 6, 0. 3 plus 5 plus 0, 8. Negative 20 plus 9 plus 16. So 16 plus 9 is 25, minus 20 is 5. Minus 5 plus 15, 10, minus 24, minus 14. And that is your answer. So minus 5 plus 15, so 15 minus 5 is 10, minus 24 is minus 14. C. CB. 4, 3, negative 4, 1, 5, 6 times 3, 1, 0, negative 5. There's no way I can. This is much too crammed. Okay. Everything's mushing into one. I can't do that. Okay, so let me make much more space. Okay. Four, 3, negative 4, 1, 5, 6. 3, 1, 0, negative 5, 3, negative 4. Okay, so now 12 minus 5, 7. 4 plus 3, really, 7. 0 minus 4, negative 4. 9 minus 25, minus 16. 3 plus 15, 18. 0 minus 20, negative 20. Negative 12 minus 30, minus 42. Minus 4 plus 18, 14. 18 minus 4 is 14. 0 minus 24, negative 24. And that is your answer. Questions about that? There's a lot of multiplications going on there. Any questions about that? All these horrible multiplications. So it's not hard, but there are just too many multiplications going on. Why were they invented? um, so they were actually they were invented really to solve systems of linear equations, and so uh, these sort of things. And if you notice, uh, one of the ways to solve systems of linear equations is just to look at them as matrices. It turns out that actually this concept of matrices turns out to be very, very important. It gave us the subject of, well, linear algebra, which is probably the basis of most of mathematics that we do. Okay. 12. No, really more calculating things. So matrices and all that are very well. They extend to everything. The linear algebra sort of stuff extends to like more or less every subject eventually. Okay, 12. Given this non-singular matrix, A, find the inverse. So let's just write down this function, this matrix. Right next to it, a identity matrix. And now let's pivot. And so this is equal to 1 minus 1 minus 1, 1, 0, 0. Okay, do nothing there. 0 minus 2 minus 1, 0, 1, 0. Now I want to make this 0, so I'll take row 3, subtract row 3, subtract 4 times row 1 to give me a new row 3. Okay, so 4 minus 4 is 0. 4 plus 3 is 7. Uh-oh. 7. And then 4 plus 0 is 4. Okay, and so negative 4 plus 0 is negative 4. 0 plus 0 is 0. 0 plus 1 is 1. Okay, so far so good. It's going to have fractions no matter what. Unfortunately. So this is equal to, let's take 1/2 of row 2 to give me a new row 2. So multiply by negative 1/2. So 0, 1, 1/2, 0, negative 1/2, 0. Okay, I want to make this 0, so you're going to take row 1, add to it row 2, okay, let's see if I can do that. Row 1, add to it row 2 to give me a new row 1. Okay, so 0 plus 1, 1 minus 1, 1/2 minus 1, 0 plus 1, negative 1/2 plus 0, 0 plus 0. Okay, next, I want to make the 7 0. And so, take row 3, subtract 7 row 2 to give me a new row 3. So 0 plus 0, 7 minus 7, 4 minus 7/2. 8/2 minus 7/2 is 1/2. Negative 4 minus 0. 7/2 plus 0 is 7/2. And then 0 plus 1 is 1. Okay. Lastly, so I want to pivot on this guy. Oh, but don't worry about that yet. Okay, so let's do, oops, the following trick. Okay, so let's do, before I even change it to 1, let's just do row 1 plus row 3 gives me a new row 1. So just add these. So 1, 0, 0 plus 1 is 1, 0 plus 0 is 0. 1/2 minus 1/2 is 0. 1 minus 4, negative 3. 7/2 minus 1/2. 6/2, which is 3. 1 plus 0 is 1. Good. And now let's subtract. So I'll take row 2 minus row 3. Give me a new row 2. So 0 minus 0, 1 minus 0, 1/2 minus 1/2. Oh, you stupid. 1 minus 0. 0 minus a negative 4. Negative 1/2 minus 7/2 is minus 8/2. 0 minus 1. These are all nice numbers. And now just take 2 times row 3 to give me a new row 3. So that gives you 0, 0, 1. And multiply everything by 2, negative 8, 7, 2. So therefore, the inverse is nice. Negative 3, 3, 1, 4, negative 4, negative 1, negative 8, 7, 2. That is my inverse. That was A. So B says to compute A times A inverse. So let's do A. Okay. B times A inverse. -3, 4, -8. 3, -4, 7, 1, -1, 2. Okay. 1 times -3, -3, 1 times -4, 1 times, -1 times 4 is -4, and then -1 times -8 is 8. 8 minus 4, 4 minus 3, 1. So next, let's do this. 3 plus 4 is 7 minus 7, 0. 1 plus 1 is 2, minus 2 is 0. 0 plus 8, 0 minus 8 plus 8, 0. 0 plus 8 minus 7, 1. 0 plus 2 minus 2, 0. Minus 12 plus 12 plus 0, 0. 12 minus 12 plus 0, 0. 4 minus 3 plus 0, 1. And that's your answer. Which is what you would hope that a quantity times its inverse times its multiplicative inverse is the multiplicative identity. Okay, that's it. Okay, any questions? Yeah, yes, it is. Okay,